Good morning, friends. Good morning, friends. I am Manish Kumar, working as a lecturer at Government Women's Polytechnic, Patiala, and my today's topic is architecture of hot and arid climate. So let's start. We all know that our habitat, buildings, etc., are greatly influenced by many factors, and the single most important factors amongst them is climate of that particular region or area. So it is very important for an architect to know about the different regions and their climatic characteristics so that he or she can plan accordingly and effectively. This is the slide showing various parts of the world with hot and arid climate. We can see this is some parts of the North America, some parts of the South America, whole South Africa, all Gulf countries, Afghanistan, and lot of parts of Australia. This type of climate prevails around 15 degrees from equator in the northern hemisphere and 30 degrees from equators in the southern hemisphere. This slide shows hot and arid climates in India. This part in red shows hot and arid climate. In India, this type of climate can be experienced in Rajasthan, Gujarat, Maharashtra, and some parts of the Madhya Pradesh and Karnataka. Now let's study characteristics of hot and arid climate briefly. This slide clearly shows what type of climate is there. We can see harsh sun, high temperature, dry land, dusty winds. First characteristics is temperature. In this type of climate, temperature is usually very hot. It can very easily go up to 50 degrees and even more in summers. The difference between day and night temperature is very high. It can vary from 15 to 20 degrees Celsius. That is, nights are comparatively cooler. Humidity. Due to very hot and harsh sun rays, humidity is very low. It generally varies between 10 to 50%. Next is precipitation. As the air is totally hot and dry in this type of climate, precipitation is very low. It may vary between 50 to 150 mm per year. This slide shows effect of low precipitation. We can see soil is very dry, there are a lot of cracks, and it's almost barren land. Next characteristics is sky conditions. Sky condition is normally good. Sky is normally clear and blue in this type of climate. Sometimes dusty storms fill complete sky, and these dusty skies create unbearable glare. So there are glare problems. Next is solar radiations. Solar radiations are direct and strong during daytimes, and these often escapes into open clear skies during nights. Yes. Next is wind. High speed dusty winds are very common for this type of climate. Wind speed may vary between 20 to 30 kilometers per hour. Winds often change direction locally. That is, lot of local factors plays very important role in the direction of wind. Next is soil and vegetation. Soil is very loose and sandy. Low humidity and less rainfall results in poor vegetation. Only thick-leaved and thorny plants can easily survive here. This is slide showing desert land. We can see vegetation is very less, and this is the kind of vegetation which survives here. We can see thick leaves which help in keeping the moistures intact. So these were the characteristics of hot and arid climate. Now, what should be our main aim while we design in this type of climate? First, architect's main aim is to avoid hot sun and as far as possible. Second, to capture as much cool air as possible. Third, to provide protection from dusty storms. So these are the main thrust areas which architects or builders should concentrate on. First, we should avoid sun. Second, we should capture cool breeze. Third, we should provide some sort of protection from dust storms. And all this can be achieved to some good extent by taking some suitable measures. We will start with the typical rural settings, how they used to protect themselves in this type of climate. This slide clearly explains everything. We can see these are typical rural dwelling units. Basically, wall is totally dead with very few windows, very few small windows. We can see one and small. And outside is light in color. Walls are thicker, we can see here. So this is a typical rural house with some of the elements which protects them from hot and arid climate. Thicker walls, smaller openings, light colored exteriors. This is another slide showing rural setting of hot and arid climate. Here we can see this mountain type structures. So sun affects them sun's effect is very less on these structures because of their shapes. Next, rural architecture of hot and arid zones. First, exterior looks is almost dead to avoid sun. We have seen already in slides. Second, exterior is light in color again to avoid absorption of heat. Third, surface area exposed to sun is minimum. Yes. Next, units are embedded deep into the ground. Thicker mud walls act as a good insulating materials. Smaller sizes of windows limits glare of solar radiations. Streets are narrow. Units are very closely placed. Next, we will discuss in today's urban areas or today's cities. First, we will discuss what type of site should be selected for this type of architecture. Site should be near the source of water. Second, and it is always better to build towards leeward side of an irrigated area because the moistures of the irrigated area may lower the air temperature. This point will be clear from this slide. Here this shape shows irrigated areas. Say wind is coming from this direction. At this point wind is hot and dusty. This will move over this irrigated area and some dust and heat will be absorbed by this irrigated area, and the wind reaching here will be cooler, comparatively cooler. So this way we can place our dwelling units next to irrigated areas and leeward side. Next point is narrow valleys should be avoided because this may become solar traps with the mountain sides heating and radiating heat back and forth again and again. This point will also be clear with this slide. So this is one mountain, this is second mountains, and this is the valley. This is not suitable place for such type of climate because when sun rays will fall on these mountains, they will reflect and a heat trap will be formed in this area. So narrow valleys should be avoided for constructing in hot and arid climates. Next is orientation. Orientation means how we should place our buildings. So first point is north-south orientation must best suits for this type of climate, and it is and it protects from morning and evening solar radiation. So best orientation for this type of climate is north and south, as it will protect us from the morning and evening suns. Second, apart from this, local site conditions and its surroundings also plays major important role in deciding orientation. It is very important. We should also see the local site conditions and surroundings while deciding orientation. Next, bedrooms should be oriented to receive cool night air. After orientation, we have house plans. House plans, compact plans are preferred as these will expose minimum surface to harsh solar radiations. Yes, our planning should be compact to avoid solar radiation. Second, deeper rooms are better against hot outside solar radiations. This point will be clear from this slide. Say this is a room, this is not deep and sun is here, so its radiation will go throughout the room and heat up this room. So if our rooms or building is deep, so this is an example of deeper room. So this is a plan. We can see sun rays will go inside the room, but these rays will not go to this place. So this place is comparatively cooler. Sun rays will be less harsh here. Yes. Next point is inward looking plans best suited for this type of climate, as these straight away protects from external solar heat and radiations. Yes, introvert planning is good. Next, courtyard planning along with some trees and small water body creates very good cool microclimate, as evaporating cooling effects occur in this type of courtyards. Yes, courtyard planning best suits for this type of climate. Courtyards creates microclimate which cools all the parts of building surrounding courtyard. So this is a just sketch showing how we can create courtyard and provide different functions of a building or house around this courtyard. Courtyard with small tree, we can provide small water body also, and we can provide external walls little thicker and with some insulating materials. Here evaporating cooling will take place, and this will be the most comfortable outside area of this dwelling unit. Next, thicker external walls with minimum windows should be used to avoid heat and solar radiations. Yes, outside windows should be small and high. Heat producing areas should be separated from other areas of the house. Yes, we should separate areas which produce heat. Next is roof. Roofs too should be insulated from hot solar radiations. Thicker insulating material should be used for this. A light colored or totally white terrace surface will reduce effects of hot solar radiations. Yes, as we know, white color will reflect most of the solar radiations, so our roof will be little less hot if we paint that white. Roof should be made higher so that radiation from ceiling is less harsh and there is enough space for hot dissipated air. Yes, this is also very good point, as our roofs also radiates heat downward. So if these are little higher, these will radiate less radiations. Next, walls. The walls of daytime living areas should be made of heat storing materials so that these can store heat in daytime and keep the inside cool and radiate hot solar radiations back into the atmosphere during night. So our main activity areas of the day like living rooms etc. should have a thicker walls so that they can absorb outside solar heat. This slide shows different spaces and direction of prevailing winds and type of construction. We can see that wind moves in this direction. This is wind direction, Here we can see this is our living room with thicker walls. This is bedroom, this is bedroom, this is washroom. We can see that bedroom walls are thinner and lighter material, thinner and of lighter materials, and living area spaces are thick walled. So in the evening we can open these windows and cool breeze will come inside, cross ventilate the space, and hot radiations emitted from this unit will also escape towards outside of the house. This dotted line here shows projections or broader eaves, passive solar eaves overhang. So this explains the previous point. Next, walls. Eastern and western walls should be shaded with trees or some other screens. Yes, like eastern and western. In east and west, sun is at lower angle, so walls should be provided with some sort of shady trees or some other screens, or we can provide double wall construction with proper ventilation may also be constructed on western side. Next point is openings. External openings should be small, as we have already seen. Eastern and western side windows should be protected by trees. Large glass areas should be avoided, as glazed areas traps heat, so it will be very difficult for this type of climate. Deep sunshades are required to shade windows effectively. Yes, to completely shade the window, we need deeper chhaja projections and sunshades. Next, it would be more effective if we somehow separate our sunshades from main structures. This is very important point. By separating the chhaja projections or sunshades, we can separate the source of heat from the main building, and heat transmitted through conduction and radiation will be less if it is separated. Next is window sill should be higher to provide dust protection. Yes, as winds in this type of climates are dusty, so we can give some sort of protection by raising the sills. As dust is heavier, it remains along ground. Ventilators should be provided to dissipate solar or any other heat trapped near the inner ceilings. Yes, as we know, hot air rises, so there should be a escape route near the ceiling, so ventilators are very good for this. Windows should be deep recessed into walls to avoid heat and glare. Yes, windows should be recessed so that there is less heat and glare. Next we comes to interiors. Light cool colors should be used for interiors. Surfaces that may reflect radiation should be painted dark to reduce glaring effect. Dark surfaces should be avoided, as these would absorb heat. Yes, generally external surfaces should not be darker, as darker colors absorb heat. Light colored or shining reflective surfaces should be used to reflect solar heat. Yes. Provide as much green surfaces as possible, as this will cool the surroundings. Yes, green surface or trees, vegetation, etc. create microclimates, and they absorb lot of heat, as all these plants need sunlight to prepare their food, so they absorb lot of light. Next, avoid hard paved surfaces, as these may create glare and radiate heat inside the building. Yes, hard surfaces will absorb the heat and also radiate heat towards the building. This slide clearly shows how paved surfaces will increase the radiations inside the building. Say this is a building, this is hard paved surface outside building. When sun rays will strike this hard paved surface, these will, on striking the hard surface, rays will travel like this and go inside the building. So this will create lot of uncomfortable situations. uncomfortable positions inside the room. So what we can do is we can cover this surface with some sort of vegetation, green covers, or some undulations. It should not be hard, smooth surface basically. Next, building should never be designed on stilts, as it would be attacked by solar heat and radiations from all sides. This is very good point. So our building should not be raised on columns or stilts. This will make the building attacked from all sides by suns and solar heat and radiations. Not from top, sides, but from bottom also. Rather, it should be embedded in ground to some extent. Yes, it should be close to ground, or even it is better if it is little bit embedded in the ground. Here this slide clearly shows a good building for this type of climate. We can see it is its height is very less. It is almost embedded in the ground. We can see ground is going up to here from side. So it is very low height building embedded in the ground. It is very good for this type of climate. A well protected embedded in ground building fights better this type of climate. Yes, it's good example. Second, glass facades buildings should be provided with large verandas in front of glass wall to cut glare and heat. If we are providing glass facades, these glass facades should be properly protected. One way is we can provide large overhangs, verandas, etc. Second, facades can be tinted. Glass facades can be tinted to reduce the effect of radiations and glare. Next, there are some more construction techniques and materials used for hot and arid zones. This is example of a wind tower used for cooling interiors and capturing breeze. This is generally situated, these are inlets for wind. It is quite high. So slide showing wind tower at higher level to catch dust-free winds and transfer it into buildings. These towers can be provided with some sort of water source or water sprinklers inside. So hot dusty wind will travel from these inlets, go through some sort of water sprinkler inlets, and the air received inside will be little cooler and dust free. This is another slide showing how we can protect our inner rooms or buildings from dusty hot winds. This is a vertical section showing how dusty hot winds is cooled and made dust free before entering the room. Just understand this. This is a room. This is the inside of a room or a building. This is external wall. There is a opening in the external wall at higher level from ground. Hot and dusty winds enter from this. Wind goes like this, strikes this wall. This will make dust to settle down here in this dust settling pit. And this is a water sprinkler inlets. So wind will go like this, dust will fall down, and it will be little cooler. And from this arrow shows dust-free cool wind. So water will filter the air, cool the air, and heavy dust will settle here. So basically this window is not direct. Wind is coming from here, then wind is modified, cooled, made dust-free, and this window receives dust-free cool air. This is also a very good example. This is cavity wall. Cavity walls are also help in limiting penetration of solar heat and radiation inside the buildings. This sketch showing a cavity. This is outer wall. This is inner wall. This space here is a cavity. Basically this will This will stop the heat from going this wall to this wall, as there is a gap. This cavity can be filled with some heat insulating material also. Some construction here, this is also a vertical section showing double glazed windows which lets the light come in and keep the heat out. This is very good example of a double glazed window. Here we can see this is wall, this is sill, this is a window frame. We can see two parts of glass. This is external glass, this is internal glass, this is a gap filled with argon gas. In this system, light will pass through this, but heat and solar radiations will be reduced inside the building because of this gap which is filled with argon gas. Low heat emitting devices should be used inside buildings. As we know, a lot of modern devices emit heat, so we can change these with low heat emitting devices like our normal bulbs radiate heats, and compact fluorescent lighting releases very less heat. Heat producing surfaces should be separated from main activity areas. We can separate heat producing areas or heat producing devices from our main activity areas also. This is another example. This is hollow block. Hollow blocks construction technique also help in thermal insulation of buildings. This is example of a concrete hollow block. We can see voids here. Construction with these type of blocks will also help in limiting the heat inside the building. Double roof technique protects main structure from solar heat. This is very good example of a double roof. Here we can see these are vertical columns 1, 2, 3 and 4 hidden here. These columns supports this roofing structure, and this roof is independent of this block. This is our main block. It has its own roof and another roof which is basically for protecting from solar heat. You can see here is a gap between these two roofs. There is a good gap of 3 to 4 feet so that heat can be dissipated from this area also. If there is a trapping of heat, it is open. This roof will basically provide some sort of protection to this dwelling unit from hot midday sun. Another slide showing double roof technique to protect main structure from solar heat. This is also another example. Here this is a massive roof with projections, overhang. This will also protect this lower building from solar heat and radiations. We can see there are a lot of gaps for free movement of air so that heats can be released back into atmosphere during nights. This is also another example of modern building with separate roof. We can clearly see these 1, 2, 3. These are main building blocks, huge building blocks, and this thin layer of separate roof. This roof will protect these 3 blocks from solar radiations and heat. And this top roof can be fitted with solar panels, and those solar panels will absorb all heat and convert this heat energy into useful electricity. Hot solar radiations can be converted into useful electricity by using photovoltaic cells. This is very good example. All terraces of hot and arid climates can be fitted with these type of panels. These panels will act in 2 ways. One, they will absorb all the solar heat and radiations and convert those heat and radiations into electricity. and these panels will also sheet this terrace. So here we can see this is a gap between roof and panel. So this surface or this terrace will be under continuous shade of these panels. Sun protection devices like pergolas are used to protect front facades of hot and arid regions. This is very good example of hot and arid building protected by pergolas. These are projected pergolas